Hello, my name is Sohail Shaikh and presenting FractalNet, an ultra-deep neural network similar to ResNet but without residuals. FractalNet is an ultra-deep neural network proposed by Gustav Larsen and his team around 2016. It is a variation of ResNet and developed to address vanishing or exploding gradients and is based on the concept of self-similarity as in fractals. Fractals are geometric shapes containing self-similar patterns at various scales. An example of fractals is shown here using famous Mandelbrot set. Recently, various deep neural networks emerged using basic CNN architectures such as ResNet, BGG, FractalNet, etc. These proposed networks use different techniques to address vanishing or exploding gradients. CNN, it is based on concept of convolution shown below. It takes an input, applies a filter and creates a resulting matrix. Here is an example of CNN architecture to recognize images. My research started with reading FractalNet research papers several times around and comparing with ResNet and few other research papers cited. FractalNet is architected around self-similar nodes, which is a CNN node at its lowest level. These CNN nodes make up an internal block. Several of these blocks are connected via join layers. Join layers combine different paths using element-wise mean, unlike other networks. Paths are systematically removed from the network during training and are called drop paths. These drop paths help with regularization and prevent co-adaptation. Shorter paths also allow quicker but moderately accurate results. FractalNet team demonstrated that reducing the effective depth using drop path is the key to better accuracy. Here is the basic building block of a FractalNet network. Let's start with the basic node consists of a convolution node. These nodes are connected sequentially as columns, and then these columns are joined by a join layer. A join layer combines outputs of various nodes or previous nodes into a single input to the next layer. At the next level, these inner blocks and columns are combined via join layers and become a block. These blocks are connected via pools shown in yellow color. The last layer is the prediction layer. Here you can see the entire network in its entirety. You can see on the left hand side there are 5 blocks connected via pools, and then the last layer in blue color is the prediction layer. And these are the depiction on the right is showing basically the column structure. One important aspect of FractalNet is the notion of drop path used to prevent vanishing gradient problem. It uses 2 strategies: local drop path within a block and a global drop path that creates a single path through the entire network that provides several benefits such as quicker result, prevention from co-adaptation and vanishing gradients. Local drop path is shown as grayed out columns here. These are grayed out columns. These are grayed out columns. Global drop path picks one column for the entire network. For example, in this case, you see a one column. It will go through the entire network. Unlike other similar neural networks, FractalNet deepens and widens as necessary. I experimented with 20 layers and 40 layers that uses 3 columns and 4 columns respectively. Some of the advantages of drop paths are prevention of co-adaptation and also provides as a diagnostic tool. The formal definition of FractalNet architecture is presented here. It shows the mathematical structure behind layers, blocks, columns, etc. Experiment set up in the paper, and I followed the same structure. It uses 5 blocks and 3 and 4 columns. Results are as reported by the paper, used as a benchmark to compare my own results. FractalNet authors reported superior performance comparing with ResNet and few others. Results as reported by the authors in the paper. results shown here. As you can see, C400 experiments were completed and some of the reported results are shown. Comparison. Here is a very a simple a summary comparison of FractalNet with ResNet and DenseNet. And here is the pictorial depiction of all three networks that I used for my research. Thank you very much for listening.